Good morning. Welcome to this presentation on cubic crystal system. Here we are going to see about the types of cubic crystal system, characteristics of unit cell, and the summary. Types of cubic crystal systems. There are mainly three types of cubic crystals. One is simple cubic structure, second one is body-centered cubic structure, and third one is a face-centered cubic structure. Simple cubic structure is otherwise called as a primitive cubic cell. Here simple cubic means there are atoms at the 8 corners of the cube. Body-centered cubic structure is apart from the 8 corner atoms, there is atom at the center of the body. Face-centered cubic structure means there are 8 corner atoms and the atoms at the 6 faces of the cube. Next, we are going to see about the characteristics of a unit cell. Volume of the unit cell, here it's a cubic, therefore the volume is A cube. Number of atoms per unit cell, the coordination number, which is the number of equidistant nearest neighboring atoms. Atomic radius, half the distance between the nearest neighboring atoms. Atomic packing factor or packing density or packing fraction. That is the ratio of the volume occupied by the atoms in a unit cell to the volume of the unit cell. Here we will explore the unique arrangements, packing fractions, and various applications. Crystal structures play a crucial role in engineering as they determine the physical, chemical, and mechanical properties of materials. At the heart of these structures lies the distinct arrangement of atoms or molecules in a repeating pattern, resulting in a solid with a well-defined shape and symmetry. Understanding the packing fraction or the packing density is essential in engineering crystal structures. This parameter affects the material's density, strength, and conductivity, making it a vital consideration in designing high-performance components and nanomaterials. It is used in, for example, it is used in aerospace engineering. Crystal structures are utilized to develop lightweight and robust materials for constructing aircraft components. In electronic, crystal structures form the basis for semiconductors, enabling the fabrication of microchips and electronic devices. Examples like this demonstrate the significance of crystal structures in real-world engineering applications. Now we are going to see about the structures. First one is the simple cubic structure. As already told, the unit cube of this structure has atoms only at the corners of the cube. Then we have to calculate the number of atoms per unit cell. There are 8 corner atoms. Each corner atom is shared by 8 unit cells. Hence, the share of each unit cell is equal to 1/8 of an atom. Therefore, the total number of atoms in a unit cell is 1/8 into 8. We cancel this side, we are getting 1. Therefore, the number of atoms per unit cell is equal to 1. This is A. Therefore, the atomic radius is half the distance between the neighboring atoms. Therefore, it is A/2. Coming to the coordination number, that is the number of nearest neighboring atoms in the unit cell. We know that there are atoms here at each corners of the unit cell. Any corner atom has 4 neighbors in this plane and 2 nearest neighbors exactly above and below. Therefore, the coordination number is 6. Next, we have to calculate the atomic packing factor. Atomic packing factor or packing fraction is equal to the volume of all atoms in the unit cell to the volume of the unit cell. Therefore, here this one is number of atoms present in the simple cubic structure into the volume of the atoms is spherical in shape. Therefore, the volume of the atoms is 4 by 3 pi r cube. Volume of the unit cell is a cube. That is the side of the cube is a. Therefore, the volume is a cube. Therefore, we have to simplify this by putting a is equal to 2r. If we put a is equal to 2r means this 4 pi by 3 to r cube this 2r cube is nothing but 2 cube is 8 into r cube. Therefore, r cube cancel this 2. Therefore, pi by 3 into 2, 6. Pi by 6 that is equal to 0.52. Therefore, the 52% of the atoms are packed. Therefore, it is loosely packed. This is rare due to low packing density. Only polonium has this structure. Next one is body-centered cubic structure. The unit cube of this structure has atoms only atoms at the corners and also an atom at the center of the cube. The number of atoms per unit cell is, we know that the 8 corner atoms is shared by 8 other unit cells. Therefore, it is 8 into 1 by 8 plus 1 center atom. Therefore, 1 by 8 into 8 plus 1. Therefore, it is equal to 2 atoms. We have to calculate the coordination number. Here the coordination number is 8. For any corner atom of the unit cell, the nearest atoms are the body-centered atoms. The nearest atoms are the body-centered atoms, and corresponding to each corner atom of the unit cell, there are 8 unit cells in neighbor which are having 8 body-centered atoms. Therefore, the coordination number is equal to 8. The coordination number is equal to 8. Next, we are going to calculate the atomic radius. In BCC crystal structure, the atoms touch along the body diagonals. The atoms touch along the body diagonals. Therefore, if you are taking the triangle, this triangle, AD squared is equal to AC squared plus DC squared. Therefore, AC squared is equal to BC squared plus AB squared. Therefore, A squared plus A squared 2A squared. If we draw this is 2R AD, this is 2R, this is R, this is R, therefore this is equal to 4R. These two are AD, therefore equating these two, 4R is equal to root 3A, therefore R is equal to root 3 by 4A. Therefore the atomic radius R is equal to root 3 by 4A. Coming to the atomic packing factor, the packing fraction is equal to volume of all atoms in the unit cell to the volume of the unit cell. Therefore, here the number of atoms is 2. The volume of the atoms is 4 by 3 pi r cube. And the volume of the unit cell is a cube. Simplifying this, we put R is equal to root 3 by 4a. Therefore, this is 8 pi by 3a cube into root 3 by 4a cube. For cancelling this and simplifying this, we are getting 0.68. Example: chromium, iron, tantalum and molybdenum. Here 68% of the atoms are packed. Therefore, it is also a loosely packed structure. Next, face-centered cubic structure. The unit cube of the structures has atoms at the corners and an atom at each face. 6 face atoms at each face of the cube. For calculating the number of atoms per unit cell, here the number of atoms is 4. The number of atoms is 4. We know that there are 8 corner atoms. Each corner atoms are shared by 1 by 8 through its unit cells, and there is a 6 face-centered atoms, and this contributing about half to unit cell, 1 by 2 to unit cell. Therefore, the total number of atoms present is 1 by 8. This is due to corner atom, plus this is due to face-centered 6 face. Therefore, cancelling this 1, this is 3. Therefore, 1 plus 3 is equal to 4. Therefore, the number of atoms per unit cell is equal to 4. Coming to the coordination number. Coordination number is the number of nearest neighboring atoms in the unit cell. In this type of the structure, for any corner atom of the unit cell, the nearest are the face-centered atoms of the surrounding unit cells in its own planes, and 4 face-centered atoms above and 4 face-centered atoms below. Therefore, the coordination number is in its own plane 4, above plane 4, and the below plane the atoms are 4. Therefore, totally 12. For calculating the atomic radius, if you are taking this is 2r, this is r, this is r. Here it is given from this triangle. AC squared is equal to AB squared plus BC squared. Therefore, this is A, this is A. Therefore, A squared plus A squared 2A squared. But here AC is equal to 4R. Therefore, 4R squared is equal to 2A squared. A is equal to root 8R. Otherwise, 2 into root 2R. To calculate the atomic packing factor, we know that it is volume of the atoms in the unit cell to the volume of the unit cell. Here the number of atoms are 4. Therefore, 4 into 4 by 3 pi r cube divided by A cube. Substituting the value of A as root 8R. A as root 8R. It is 0.74%. Example, therefore 75% of the atoms are packed. Therefore, it is said to be the closely packed structures. The examples are aluminium, copper, nickel, gold, etc. Therefore, the summary, this is unit cell volume for simple cubic structure. Bodies and all are cubic in nature. Therefore, it is A cube. Number of atoms per unit cell is simple cubic 1, body centered 2, and face centered atom 4. The coordination number is 6 for the simple cubic, 8 for the body centered, and 12 for the face centered. Atomic radius is A by 2, root 3 by 4A, A2 root 2. Density of packing is 0.52, 0.68, and 0.74. Examples: polonium, iron, barium, chromium, aluminium, lead, copper, gold. Thank you.